After losing the valence electrons in requisite number which is equal to oxidation state, then it will be having vacant orbitals. Say for example, what I would like to select is again the same cobalt is there. You know the cobalt, one it is the atomic number of cobalt is iron cobalt, that means 27 and its configuration is the outermost only I am writing, or this one is argon, this one is 3d7 4s2, 3d7 4s2. Now then in the complex what we concluded, CO NH3 taken 6 times 3 plus the oxidation state of cobalt is plus 3. So therefore it is losing outermost 3 electrons, 2 electrons from this s orbital and 1 electron from d orbital. So therefore the cobalt plus 3 configuration is argon 3d6 4s0. So I can rewrite what means I can show this one, this configuration with orbital method like this. I am showing only outermost, the one it is 3d6, it is normal configuration 1 2 3 4 5 6 and s orbital is 0 without any electrons. This is 3d and this one is 4s, along with 4p orbitals are also vacant in the fourth shell, 4p orbital, along with that one even 4d orbitals are also vacant. So therefore after losing requisite number of electrons, these metal atoms or ions are having certain vacant orbitals. Now whenever a ligand is approaching during the formation of complex, what is happening? A ligand approaches and it forms a day-2 bond. So therefore whenever a ligand is approaching, what will happen? The rearrangement of these electrons takes place in the d orbital. It depends upon the nature of the ligand. Some ligands can influence this metal atom or ion more effectively, which are named as strong field ligands. They are known as strong field ligands. Strong field ligands. Some ones they cannot able to influence this central metal atom or ion more effectively, and they are known as weak field ligands. Weak field ligands. So therefore during the formation of complexes, what is happening? The ligands are surrounding this metal atom or ion to form day-2 bonds. While they are grouping and they are coming around this central metal atom or ion, then what happens? Some of the ligands they are influencing this metal atom or ion more effectively, and such type of ligands are called as strong field ligands. For example, Cn minus, cobalt, this one, that means carbon monoxide, or say for example what means any organic ones, such ones they are affecting very much. These ones are called as strong field ligands. Whereas some other type of ligands they could not able to influence this metal atom or ion so effectively. Such ones are called as weak field ligands, such as H2O, okay, Cl minus or Br minus. These type of ones they could not able to influence this one much effectively, and such ones are called as weak field ligands. Very important thing is here, okay, he actually while explaining valency bond theory, these postulates whatever there, they are based on experimental facts. That means more postulations are present. So therefore what it is happening means they are not explaining why some ligands are influencing and they are called as strong field ligands, why some ligands are influencing less effectively and why they are called as weak field ligands. There is no what means explanation, theoretical explanation is not present this one. There is another theory what actually learned by us in the higher studies, ligand field theory, that explains the influence of the ligands. At this stage we are limited, just we are recognizing and by the experimental fact, and we are suggesting these are working as strong field ligands and these are working as weak field ligands. So therefore, in such a case, whenever strong field ligands are there, since their influence is more, then what happens? The d orbital electrons are paired up and they are rearranged. That means here the 3d6 can be written as in this case where NH3 is looking as a strong field ligand for cobalt plus 3, and what happens means these are paired up in 3 orbitals. Other 2 orbitals of d orbitals, they are vacant along with 4s as well as 4p, this one. Whereas if that one is, this cobalt complex is with water, then that pairing does not take place. So therefore, that one rearrangement does not occur. Here the rearrangement occurs. Now these are the orbitals which are present vacant. These are the orbitals which are present vacant. In such a case, these orbitals which are present vacant, they undergo appropriate hybridization. Remember again, I am using a word, appropriate hybridization. These vacant orbitals which are present, they undergo appropriate hybridization. Here, to accommodate 6 dative bonds which are present octahedrally, then it requires 6 hybrid orbitals which are obtained from these 2 d orbitals and 1 s orbital and 3 p orbitals. That means it undergoes what type of hybridization is D2sp3 hybridization. What type of hybridization? D2sp3 hybridization. So this is the meaning of appropriate hybridization. What is the meaning of appropriate hybridization? I am going again. There are 6 dative bonds which are formed by 6 NH3 ligands, and these are present octahedrally. How we know that is present octahedrally? That what I am saying, the valence